Alright, so in the last video we just went over a brief interview to what to expect in the next few videos, like repeated roots, distinct roots, and complex roots. But in this episode, we're going to start Unit 2 with non-homogeneous differential equations with constant coefficients, but the distinct roots case. So you might recognize this. We used this a little bit in our last video, but remember that what we do is we treat this as like a quadratic equation, and we just use these coefficients for r squared, r, and then just no r. And then we'll factor it out, and we will find what r is roots. We'll find out what the roots are. It's just something that's hard to explain, but you'll notice that it's actually pretty easy. We just need to do some examples. So let's jump right into it. So right here we just have r squared as coefficient of 1 plus 11r plus 24. And then we factor this out. We got 3 and 8. Those add up to 11, so we get r squared plus 3r plus 8r plus 24. And we end up getting r times r plus 3. My writing is really bad today. R plus 3 plus 8 times r plus 3. So we get r plus 3 and r plus 8. So our roots are, and this all equals 0, so our roots are r equals -3, r equals -8, or r1 and r2. And when r1 doesn't equal r2, we use the distinct roots case, which, well, first let me write our initial conditions. Y of 0 equals 0, y prime of 0 equals 7. And we'll get to that soon, but what we get is y of x equals c1 e to the r1 x plus c2 e to the r2 x. And we have these initial conditions so we can find these coefficients. But our general solution is very simple. It's just y to the x equals c1 e to the -3x plus c2 e to the -8x. And we can plug in 0 and everything, but we also need a second equation. And, well, we got a hint right here. Our second equation that we need is going to be the derivative. That way we can use two initial conditions. Because you can't find two variables with only one initial condition. So we will need to transform this equation into a way that we can use the second. So let's find y prime. And this is just some basic derivative rules. E to the something is just itself, so c1 e to the something times the derivative of that something. So we got a little bit of chain rule right there. And then e to the something equals that e to the something times the derivative of that something. So we end up getting y prime of x equals -3c1 e to the -3x plus -8 c2 e to the negative 8x. So these are our two equations. And we can use these to find C1 and C2. So first let's plug in y of 0 equals 0. So we got 0 equals C1 e to the negative 3 times 0 plus C2 e to the negative 8 times 0. We just got 0 equals C1 times 1 plus C2 times 1. So we get C1 equals negative C2. Now for here, we get 0 and 7. So 7 equals negative 3 C1 times e to the negative 3 times 0 plus negative 8 C2 times e to the negative 8 times 0. And that's just 1. So 7 equals negative 3 C1 minus 8 C2. And C1 equals negative C2. So we can just say 7 equals 3 C2 minus 8 C2. We get 7 equals negative 5 C2. C2 equals negative 7/5. And therefore, if C2 is negative 7/5, then negative negative is just positive. So those are our constants. Let me just double check with my notes, make sure I didn't make any errors. And we are all good. So let's just rewrite this finally as y of x equals 7/5 e to the negative 3x, and plug in C1 into here, plus negative 7/5 e to the negative 8x. And that is our final answer. So you can see generally just how you solve these problems. And it gets a little harder with repeated roots and complex roots, but by the time you get there, you would have done so many of these just factoring, find equations, plug in coefficients, that it's basically the same process for everything.